A student was assigned to determine the enthalpy change for the reaction between solid magnesium oxide and aqueous hydrochloric acid, represented by the net ionic reaction below. The student added 0.5 grams of magnesium oxide to 100 milliliters of HCl in a styrofoam cup calorimeter. She determined that the temperature rose from 24.1 to 28.1. All right, so with all of this calorimetry data, we're asked to solve a multi-step AP-style problem. So part A says, calculate the magnitude of Q, the thermal energy change, when the MgO was added to the HCl. Assume the calorimeter has a negligible heat capacity, and the specific heat of the contents of the calorimeter is 4.18 joules per gram degree Celsius. Also, assume the density of HCl is 1 gram per milliliter. Include units with your answer. Okay, so this is just a Q equals MC delta T problem, because we're given the mass of the calorimeter, contents, the specific heat, and the change in temperature. So this is the Q for the calorimeter, because we're measuring the temperature of the calorimeter. So the mass is 0.5 grams of MgO, and then if we have 100 milliliters of HCl with a density of 1 gram per milliliter, that's 100 grams of HCl. So I have 100.5 grams. My specific heat is 4.18 joules per gram degrees C. And my delta T, final temperature, is 28.1 minus initial temperature 24.1. So I get a Q here for the calorimeter of 1,680 joules. And we should see joules there because we have grams that cancel here and degrees Celsius that cancel there. So we're left with joules. So this is or 1.68 kilojoules. Both are accepted. And just to double check, 1680 joules. Okay. Part B says, determine the experimental value of delta H for the reaction in units of kilojoules per mole. So we found the heat Q for the calorimeter in part A. Remember that that's equal to the negative Q for the reaction, right? So heat gained is equal to heat lost. Okay, so the heat that the calorimeter gained in going from 24.1 to 28.1 degrees is because the magnesium oxide released that heat. Okay, so that means that Q for the reaction is negative 1.68 kilojoules based on our answer to part A. And we need per mole. So just off to the side here, if I have 0.5 grams of MgO and I divide by the molar mass from the periodic table, 40.3 grams per mole, I get 0.0124 moles of MgO. So I'm going to take negative 1.68 kilojoules per 0.0124 moles, and I get negative 135 kilojoules per mole.